All right, let's look at number 45. So for 45, we have triangle ABC where angle A is 58, side A is 5. Okay, we remember when we're trying to figure out if we're going to use law of sines or law of cosines, we need to see, do we have a pair? And we do. So that means that I'm going to use law of sines for this. And then the other piece I have is side B, and I'm trying to find angle B. So I'm going to set sine A is to A as sine B is to B. Let's plug in the three things that we know, and then we can cross multiply. So I'm going to do 5 times sine B is equal to 4.5 times sine 58. So now I need to get sine B by itself, so I'm going to divide both sides by 5. So I've got sine B is equal to this value. I'm going to throw this in my calculator in degree mode. And this is what I get. Now, we're not saying that angle B is 0.76 of 1 degree. That is the sine of angle B. So to get the actual angle, we need to do inverse sine of that value. All right, so let me switch over to my calculator and show you how we would do that. All right, so first off, I'm going to use my fraction builder, and I'm going to say sine of 58 times 4.5, and that's being divided by 5. All right, need to make sure that I'm in degree mode, which I am. And so when I hit enter, that gives me that decimal that we had gotten. And so then I'm going to do second sine. So remember, when I hit something, it lights in red. So second sine to get this inverse sine. And then I can just use my up arrow key to come back to that decimal and hit enter, and it'll retype that whole thing for me. And so there's my angle that they asked me to find to one decimal place. That would be 49.8. All right. Then for number 46, so for 46, we also have a pair. If you'll notice, it says for triangle ABC, angle A is 24.3, angle C is 54.6, and side C is 2.68. And I'm trying to find side A. So again, I'm going to do the same thing. I'm going to set my A's equal to my C's, plug in the three values that I know, cross multiply, so sine 24 times 2.68 is equal to A times sine 54.6. To get A by itself, I would divide both sides by sine 54.6. So when I put this into my calculator, I get 1.35. That is my side A. This didn't say sine angle A equals something. So I don't do inverse sine on this. That is my answer, 1.35. All right, then for 47, it said find the area if angle A is 50, side B is 10, and side C is 8. So that is a side angled side triangle. So if you look on your formula sheet, area of a side angle side triangle is 1/2 BC sine A. Now there are three formulas there, but notice that each of them only have one angle in them. So the easy way to tell which formula to use is to look at the angle. All right, so then I'm going to throw this whole thing in my calculator in degree mode, and I'll get my area of 30.64. All right, then when I get to 48, it says B is 12, C is 7, and A is 104. I do not have a pair of anything, so I'm going to have to use law of cosines. Now, if you look on your formula sheet, there are 6 different law of cosines formulas. The way that I know which one to use, all 6 of them have side A, side B, side C in them, little ABC in them, but each of them only has one angle in it. So the angle is the key. So I'm looking for the formulas that have angle A in them. So one of them solves for angle A. I don't need that. I already know angle A. I need the one that solves for side A. Okay, so here's that formula right here. So we're going to go through and we're going to put 12 in for B, 7 in for C, 12 in for B, 7 in for C, and then 104 in for A. So don't bother trying to simplify this at all, because if you don't do order of operations correctly, you're going to get the wrong answer. So make sure you just throw that whole thing in your calculator at one time. And then don't forget, you get like a really big number here. Don't forget that that's what a squared equals. You still need to take the square root of both sides to get the side length of A. And then it said round to the nearest tenth, so that would be 15.3. All right, then for 49, I have a side, side, side triangle. Again, I don't have a pair of anything, so I'm going to have to use law of cosines. And they're asking me to find the largest angle. So remember, the largest angle is going to be opposite the longest side. So 2.4 is the longest side. That means I'm finding angle B. So again, if I go back to my 6 formulas, the one that finds angle B, not side B, I already have that. The one that finds angle B is this one. So let's plug in 1.2 for A, 2 for C, and 2.4 for B, and then 1.2 and 2. I'm going to throw this whole thing into my calculator, and when I do, I get negative 0.0666, like it's just a repeating decimal. So again, we're not saying that angle B is less than 1 degree here, or that it's a negative degree. Remember that that's what cosine is equal to. So to get rid of cosine, it's inverse cosine. Second cosine of that value will give us our angle. All right, then for number 50, find the area of the triangle in problem number 49. So if we come back to 49, that was a side, side, side triangle. So we're going to do the sum of the 3 sides divided by 2 to get our S value. So that's where we get 2.8. And then if you look on your formula sheet for area of a side, side, side triangle, it's S, S minus A, S minus B, S minus C. So again, here's my S over here. And then A, B, and C are just the 3 sides of the triangle that we had up here. So throw that whole thing in your calculator at one time, and then your calculator will give you that value. All right, so now let's switch to our free response problems. All right, so for our free response problems, you want to be sure that you show all of your work so that you can get as much partial credit as possible. And there'll be plenty of space for you to do that, as you see here. All right, the views of Delaney's video of her jet ski drive-by water gun assassination of Weston are growing at a rate of 18% per day. If there are currently 500 views, how many views will there be in 5 days, round to the nearest whole number? So this is exponential growth. So on your formula sheet, you have exponential growth and decay. So growth, of course, is when it's getting bigger. Decay is when it's getting smaller. So the formula is the same, a times b to the x. B is going to be 1 plus the rate of growth if it's growing, and it's going to be 1 minus the rate of decay if it is decreasing or decaying. So it said this A value right here is going to be our initial value. So right now our initial value is 500. Then we're going to do 1 plus the rate of growth. Now, anytime you multiply by a percent, you always change it to a decimal. So I'm going to rewrite 18% as 0.18. And then X is going to be my time. So it says it's 18% per day and then 5 days. All right, so then I can just throw this into my calculator, and I find out that after 5 days, there's going to be 1,144 views because we said round to the nearest whole number. All right, then for number 2, due to Delaney's epic dedication to senior assassin and multiple assassinations this weekend, the number of students who believed that JT could beat Delaney was decreasing at a rate of 18% per day. If 100 students currently believe JT can win, how many will still believe in 5 days? All right, so again, the exact same thing, only this time because it is a decreasing quantity of 18%, we're going to say 1 minus 0.8 instead of 1 plus. And then our initial amount is 100, and again, our time is 5. So we'll put this into our calculator, and we round this to the nearest whole number, and we'll get 37. All right, then for number 3, if 4,100 is invested at a rate of 7.5%, what's the balance at the end of 10 years? If it's compounded monthly, quarterly, or daily. Okay, so that's our compound interest formula, this one right here. P stands for the principal, the original amount you're investing. R is your rate, written as a decimal again. So remember to switch from a percent to a decimal. You're going to move that decimal 2 places, so that would be 0.075. And then N is the number of times it's compounded. So since this was monthly, N will be 12 here and here. And then t is our time, and it said 10 years. So I'm going to throw this whole thing into my calculator, use your little fraction builder button to make it easier to type in, and we'll get our dollar amount. Now, the only thing that changes from problem A to problem B is the number of times it's compounded. So monthly is 12, quarterly is 4. So literally all we're going to do is replace 12 with 4. Replace 12 with 4. And you'll notice that we get a similar dollar amount. All right, then same thing with daily. Daily is 365. So I'm going to replace 4 with 365 and replace 4 with 365. And again, I'll get a similar amount. Now, if instead it says that it's compounded continuously, that is a different formula. That's our continuously compounded interest. That's our PERT formula. So again, P is still our original principal, our original amount. E is that button on your calculator. R is our percent written as a decimal, and T is our time. Now, if you've forgotten where E is on your calculator, here it is right here. So you can do E to the. There is also another E button right here that already puts the exponent on there. So either one of those, perfectly fine. All right, then for numbers 5 and 6, we're working with exponential functions and some information about them. All right, so to begin with, we want to graph the function, and I'm going to start with the parent function. Now remember, the parent function is like, what's the function before we did all these crazy transformations to it? So like you literally can put your finger over these and drop them off. Our parent function is just 3 to the x. So I'm going to throw a couple of values into that. So if I put 0 in for x, 3 to the 0 is 1. If I put 1 in for x, 3 to the 1 is 3. And if I put in -1, 3 to the -1, to get rid of a negative exponent, we move across the division bar. So that's 1 over 3 to the +1, so 1/3. So I'm going to come over here and plot those points. So here's 0, 1, and come over to 1, go up to 3, and then right here, -1, 1/3. There's my original function. And I have an asymptote that starts on the x-axis. All right, then any value subtracted from x is a horizontal shift. So that's going to be a horizontal shift of +2. So it's the opposite of that number. And then my vertical shift, I don't do the opposite of it. So my vertical shift is going to be a +1. So I can take this point right here and I can go over 2 and up 1, and there's that same point. Take this one, over 2, up 1, there's that same point. Take this one, over 2, up 1, there's that point. And if our asymptote was down here at 0 and we had a vertical shift of a +1, my asymptote now is going to be at +1. So your asymptote will be the same thing as your vertical shift. Okay, so now we've got that graph and we can identify these things they're asking me for. So what's my range? So we're looking at the blue graph. If I start down here to the bottom, you can see that it's coming right up to 1 but not touching it, and then it's going to infinity. So we could say y is greater than 1, or we could say 1 to infinity in interval notation. But notice we're not putting a bracket or an equal sign with it because we're not equal to it. All right, and then the domain you can see this is going to keep going and going this way and going and going this way. So that is going to be all real numbers. And then we've already said that our asymptote was right here at y equals 1, the same as our shift. All right, so then logarithmic. Now remember, logarithms and exponentials are inverses of each other. So I'm going to start the same way with the parent function. All right, and I'm going to, it's actually easier to plug in values for y. So if I switch this to an exponential, that's going to be 2 to the y is equal to x. So I can say 2 to the 0 is 1, 2 to the 1 is 2, 2 to the -1 is 1/2, 2 to the -2 is 4. All right, so I'm going to come over here and plot those points, and that gives me my parent function. Notice that I have a vertical asymptote right here at 0. So I have a horizontal shift of -3 and a vertical shift of -2. So I'm going to take each of these points and go over -3 and go down 2. Same thing for this one. Go over 3 and go down 2. So I can transfer point by point. And remember, if my asymptote was at 0, then it got backed up 3. So my vertical asymptote will be the same as my horizontal shift.